Welcome back, students. Last class we have discussed exercise 3.2, okay, and today we come to a new concept that is known as transpose of a matrix. Okay, so we discuss the concept transpose of a matrix with the help of an example. Okay, suppose A equal to matrix 1 2 minus 1 3 4 5 0 6 8. Okay, then the transpose of A, it is denoted by either A dash or A raised to T. Okay, but both we read as A transpose. So A dash stands for A transpose and A raised to T also stands for A transpose. Okay, now we discuss how to obtain A transpose. Okay, so A transpose is the matrix obtained by interchanging the rows and columns. The simple meaning is converting the rows into columns. Then automatically the columns get converted into rows. So what we do? Interchanging the rows and columns. It means the first row 1 2 minus 1 is to be written as the first column. The second row 3 4 5 becomes the second column, and the third row 0 6 8 becomes the third column. Okay, so what is meant by the transpose of a matrix? It is a matrix obtained by interchanging the rows and the columns. Okay, then suppose we consider another matrix. B is equal to matrix 1 2 minus 1 0 4 5. Okay, B is a matrix of order 2 by 3. Then the transpose of B, that is B transpose equal to matrix, the first row becomes the first column, the second row becomes the second column. Okay, and B transpose is a matrix of order, how many rows here? 3. Okay, and how many columns? Yeah, 2. So this is a matrix of order 3 by 2. So it is very clear, if A is a matrix of order m by n, then A transpose is a matrix of order n by m. Okay, the order get reversed. So that way we come to which one? The transpose of a matrix. Clear? So it is a matrix obtained by interchanging the rows and the columns, and we said if A is a matrix, then A transpose is denoted by A dash or A raised to T, and if A is a matrix of order m by n, then A transpose is of order n by n. Okay, now we have to discuss the important concept, nothing but which one? The properties. Okay, properties of transpose. Okay, we come to properties of transpose. Okay, among the properties, the first one is transpose of a transpose. The meaning is what? A transpose, the whole transpose is equal to A itself. So it is extremely similar to the property complement that we discussed in set theory. Okay, and we know that in set theory A stands for a set and A dash stands for which one? The complement of a set. and there we discuss complement of a complement is the set itself. Clear? In the same manner, when we come to a matrix and its transpose, what is the first property? Transpose of a transpose is the matrix itself. It is very clear. A is given, then when we obtain A transpose, the rows becomes columns. Then we obtain the transpose of A transpose. What happens? The columns again become rows. The meaning is we come back to the original matrix, or the meaning is what? The transpose of a transpose is the matrix itself. Okay. The second property is, suppose we consider the sum of two matrices, A plus B, then A plus B the whole transpose. Okay. That is equal to A transpose plus B transpose. So what does it mean? Transpose of a sum is equal to sum of the transposes. Okay. And instead of addition, if subtraction is coming, then what does it mean? A minus B, the whole transpose, equal to A transpose minus B transpose. Clear? So what does it mean? Transpose of a sum equal to sum of the transposes, or transpose of a difference is equal to difference of the transposes. Okay. Now the third property, we consider the product of a scalar K and a matrix A. Then Ka we discussed earlier. Then Ka the whole transpose. Okay. What remember? Transpose is meant for matrices. So K remains as it is and transpose of A. Okay. And like transpose of a sum, we come to which one? The transpose of a product AB. Look, in the second property, we have seen that transpose of a sum is equal to sum of the transposes. Transpose of a difference is equal to difference of the transposes. So it is quite natural that we expect transpose of a product equal to what? The product of the transposes. The meaning is what? A transpose into B transpose. Okay. But remember, it is wrong. The meaning is what? The transpose of product is not as like the transpose of a sum or difference. But difference is quite slight. Only a slight difference. Okay. And that is AB the whole transpose is not equal to A transpose B transpose, but that is equal to B transpose into A transpose. So what does it mean? It is the product of the transposes, but instead of A transpose, what comes first? B transpose. The meaning is what? Transpose of the second matrix is coming. So what is the meaning of this? Transpose of a product is equal to product of the transposes taken in the reverse order. Clear? Okay. So this way we come to the properties of transposes. Okay, and these properties have to be remembered when we discuss certain new concepts later on. We have to make use of the properties. Okay, and many a times we come across which one? The properties of transposes. Okay, so just recall it. What is the first one? Transpose of a transpose is the matrix itself. Transpose of a sum equal to sum of the transposes. Transpose of product of scalar and matrix. Scalar remains as it is into transpose of matrix. And transpose of the product of two matrices is equal to product of the transposes taken in the reverse order. Clear? Okay. So that way we have discussed the properties of transpose. Okay. Now, with the help or by using the concept of transpose, we come to two types of matrices. Okay. The first one is what is meant by a symmetric matrix. Okay, and thereafter we discuss what is meant by a skew symmetric matrix. Okay, so what we are discussing, what is meant by a symmetric matrix, otherwise when we say a matrix is a symmetric matrix, and what is meant by a skew symmetric matrix. Okay, so first of all we come to what is meant by a symmetric matrix. Symmetric matrix. Okay, so in mathematics we are very much familiar with the term symmetric. Many a times we use, especially in geometry. Okay, for example, suppose we consider an object and the image. Okay, for example, suppose a triangle or a triangular structure is placed in front of a mirror. Then, of course, is the mirror, is the triangle, and the image obtained is again which one? The triangle. The meaning is what? The object and the image look extremely alike. Clear? Symmetric. The meaning is with respect to the mirror, the object and image remain same. Okay, so the meaning is simply when we come to the term symmetric, there comes the meaning alike, similar, same in our mind. Now we see what is the definition of symmetric matrix. Okay, remember here we consider a square matrix. A is a square matrix, and we obtain the transpose of A transpose. So what is A transpose? It is a matrix obtained by interchanging the rows and columns of the matrix A. So we have a matrix A and we have a new matrix A transpose. Okay, now we just look the new matrix obtained A transpose. Okay, and suppose A transpose is nothing but the original matrix A. The meaning is what? Even after taking the transpose, the matrix remains itself. In such case, we say A is a symmetric matrix. Clear? So what does it mean? If the transpose of a matrix is the matrix itself, then the matrix is known as a symmetric matrix. Okay, and after the definition, now it is very clear why did we consider the matrix A as square? Because we know that on taking the transpose, the order gets reversed. If A is of order 3 by 2, then A transpose is of order 2 by 3. Since A and A transpose are of different orders, there is no chance of A becoming equal to A transpose. So, for getting A and A transpose, the first condition to be satisfied is A is a square matrix. Okay, and thereafter the transpose of A is what? Matrix A itself. Clear? Okay, now we discuss an example. Okay, so we are discussing an example for a square matrix. So suppose A equal to matrix. Okay, now while writing an example for a symmetric matrix, just remember we cannot write that matrix in a random order, because even after taking the transpose, we need the same matrix. So the meaning is what? The elements or the rows and columns are to be written in a specific order. Okay, the specific order is, okay, anyhow, what we need, A as a square matrix. Suppose we consider A as a square matrix of order 3 and we write the first row. Suppose first row 1, 2, 3. Okay, so after writing the first row, okay, don't write the second row, write the first column. Write the first column as the same as that of which one? The first row. Now when you write the second row, two more elements are written, suppose 4 minus 1. After second row, second column, it should be same, 2, 4, then the same minus 1. Now one element is left out, suppose it is 7. Clear? Okay. Now we obtain the transpose of A. How we write the transpose of A? We come to A, write the first row 1, 2, 3 as the first column. Second row 2, 4 minus 1 as the second column. The third row 3 minus 1, 7 as the third row. Now see, or just compare the two matrices A and A transpose. First row of A 1, 2, 3, get 1, 2, 3. 2, 4 minus 1, 2, 4 minus 1. 3 minus 1, 7, 3 minus 1, 7. What does it mean? A and A transpose are two matrices in which the corresponding elements are equal. The meaning is what? A transpose and A are equal. And by definition, what we say? A is a symmetric matrix. Okay? So that way, we discuss an example for a symmetric matrix. And we said we should be very careful while writing an example for a symmetric matrix, not to write the elements in random order. How the matrix is to be written? After writing the first row, okay, write the first column as the same. The meaning is what? Write the first row itself as the first column. Write the second row itself as the second column. Write the third row and write the third row itself as the third column. That way, we can come to which one? An example for a symmetric matrix. Okay, then as we said earlier, we come to which one? We come to skew symmetric matrix. Okay, so when we said symmetric matrix, we just said the simple meaning of symmetry. What we said? Symmetric means alike, means similar. Okay, and here with the term symmetric, the extra term coming is skew. And I think you are at least a bit familiar with the term skew. Okay, as actually I think that in the lower standard geometry, that is in 8th or 9th standard, you heard about skew lines. Okay, so anyhow, simply remember, skew means what? Deviation, change. Okay, so skew means what? Deviation, otherwise a change. So what we said in symmetric matrix, the transpose and the matrix are same. Same means what? No change. But when we come to skew symmetric, the only difference is the transpose of the matrix is not A, but there is a slight change. The slight change is what? It is negative of the matrix A. So the meaning is it is different from A, but it is not absolutely different. Okay, there is only a slight difference. What is that difference? It is the negative of the matrix. Okay, so how do we define a skew symmetric matrix? A square matrix, A is said to be a skew symmetric matrix if its transpose is equal to negative of the matrix. That is, A transpose is equal to minus A. So if A transpose is equal to minus A, what we say? A is a skew symmetric matrix. Clear? Okay. So what we said? A square matrix is said to be a skew symmetric matrix if its transpose is the negative of the matrix, and negative of the matrix is also known as what? The additive inverse of the matrix. Okay, then as we said earlier, we come to which one? An example for a skew symmetric matrix. Okay, so when we discuss the example for a symmetric matrix, we said the elements are not to be written in a random way. In the same manner, when we come to which one? An example for a skew symmetric matrix, there also some restrictions or specifications are to be followed while writing the elements of the matrix. Okay? So remember, the first condition is all the principal diagonal elements are 0. To remember, in a skew symmetric matrix, all the principal diagonal elements are 0. Now in the first row, we need 2 more elements. Suppose it is -2, 3. Okay. Now what we write? First column, how to be written? Write the opposite elements. -2 means write +2, +3 means write -3. Okay. Now we come to second row, 1 element, write any element. I am writing it as 6. Okay. Then second row 2, 0, 6 means second column the opposite, -2, 0, 6 becomes -6. Clear? Okay. Now we check whether A transpose is -A or not. And for that we write which one? A transpose. Write the first row, 0, -2, 3 as the first column, 2, 0, 6 as the second column, -3, -6, 0 as the third column. Okay. Thereafter, take minus, means -1 out of the matrix, but out of the matrix means -1 or minus is to be taken from all the elements. Okay. So 0 minus taken is 0 only. 2 become -2, -3 becomes 3, -2 becomes 2, 0, -6 becomes 6, 3 become -3, 6 become -6 and 0. See, look, we have the minus here. What is the remaining matrix? What is the first row? 0, -2, 3. See, 0, -2, 3, 2, 0, 6, 2, 0, 6, -3, -6, 0, -3, -6, 0. What does it mean? The matrix is nothing but A itself, the remaining. So what we are getting? A transpose is equal to -A. Then according to the definition, A transpose equal to -A means what? A is a skew symmetric matrix. Okay, so we discuss an example for a skew symmetric matrix. Okay, and the most important property to remember is for a skew symmetric matrix, all the principal diagonal elements are 0. All the principal diagonal elements are 0. So just remember that property. Okay, and especially in the examination point of view, a question is possible on the basis of this property. Which one? The principal diagonal elements of a skew symmetric matrix, okay, is equal to 0. Okay, so we have discussed what is meant by a symmetric matrix and what is meant by a skew symmetric matrix. Okay, now based on the concept of symmetric and skew symmetric matrix, we come to an important conversion or expression of a square matrix. Okay, so we say expressing a square matrix as the sum of a symmetric matrix and skew symmetric matrix. What we are discussing, how to express a given square matrix as the sum of a symmetric matrix and a skew symmetric matrix. Okay, we just discuss it with the help of a square matrix A. Okay, suppose A is a square matrix. Okay, A can be written as half into A plus A transpose plus half into A minus A transpose. Now we discuss actually how does it come. So anyhow, what we said, how to express A as the sum of a symmetric matrix and a skew symmetric matrix, expressing a given square matrix as the sum of a symmetric matrix and a skew symmetric matrix. Okay, look, actually if we just think of the simplification, like by using the properties of matrices, half is common from both, half into A plus A transpose plus A minus A transpose. The matrix A transpose and minus A transpose get nullified. The remaining is A plus A, that is 2A, that is half into 2A. So what will come? A. The meaning is what? The simplified value of half into A plus A transpose plus half into A minus A transpose is nothing but the matrix A itself. Okay, and sometimes for convenience we write A equal to P plus Q, where P is equal to half into A plus A transpose. This is known as the symmetric part of A. Okay, and the second matrix Q, that is half into A minus A transpose, and half into A minus A transpose or Q is known as what we call the skew symmetry. The skew symmetric part of A. Okay, so the meaning is what? The matrix A can be written as half into A plus A transpose plus half into A minus A transpose, where half into A plus A transpose is known as the symmetric part of A, and half into A minus A transpose is known as what? The skew symmetric part of A. Okay, now just to verify whether this half into A plus A transpose is symmetric or not. Okay, and half into A minus A transpose is skew symmetric or not. It's enough to actually verify only one. Okay, look, so we have taken P as half into A plus A transpose. Then P transpose is equal to half into A plus A transpose. That is P is the whole transpose. Okay, then see, half is a scalar, A plus A transpose is a matrix. Then according to the property, which one? Ka, the whole transpose equal to the scalar K or half remains same, and transpose of which one? The matrix A plus A transpose. Then according to the property, sum, what will come? Transpose of first plus transpose of second is equal to half into A transpose. And what is the first property? A transpose, the whole transpose is A itself. And we know that matrix addition is commutative. The meaning is what? The sum A plus B can also be written as B plus A. In the same manner, the sum A transpose plus A can also be written as A plus A transpose. So this is nothing but which one? P. So we are getting P transpose equal to P. The meaning is what? Therefore, P is a symmetric matrix, or simply P is symmetric. Okay. So the meaning is what? We verify P is symmetric. In the same manner we can do for Q. The only difference is what will come? Q is equal to half into A minus A transpose. Q transpose is equal to, it will come as half into A minus A transpose, the whole transpose. The only thing is this plus become minus. So the meaning is when we come to Q transpose, we reach to half into A transpose minus A. Okay, so this is, if you take the minus outside, minus half into A minus A transpose. That is minus, but half into A minus A transpose is Q. So where we are reaching? We reach to Q transpose is equal to minus Q. So what is the conclusion? Therefore, the matrix Q is, what will come? Is going to be Q symmetric. Okay, so this way we can easily verify that what? P equal to half into A plus A transpose is symmetric, and Q is equal to half into A minus A transpose is skew symmetric. So in short, we come to the conclusion what? A given square matrix A can be written as, okay, P plus Q, where P is equal to half into A plus A transpose, okay, is what? Is the symmetric part of A, and Q is equal to half into A minus, okay, half into A minus A transpose, and what is it? It is the skew symmetric part of A. So the meaning is what? When a square matrix is given, it can be expressed as the sum of a symmetric matrix and a skew symmetric matrix. Okay, and what is the symmetric part? Half into A plus A transpose, and what is the skew symmetric part? Half into A minus A transpose. Okay, so this much is enough for today's session. Okay, we just recall what we have discussed today. Okay, what was the first one we had discussed? First we discussed which one? Transpose of a matrix. Okay, then what we discussed? By using transpose, after transpose, what we have discussed? We have discussed the properties. Okay, after the properties, what we have discussed? After discussing the properties of transposes, we have discussed which one? The two type of matrices. What was the first one? Symmetric matrix. Okay. Second one, which one? Skew symmetric matrix. Okay, and thereafter, what was skew symmetric? Sorry, what was symmetric? A transpose is equal to A. What was skew symmetric? A transpose is equal to minus A. Okay, and thereafter we discuss the most important conversion, which one? Expressing a square matrix as the sum of a symmetric matrix and a skew symmetric matrix. What was the conversion? If A is the given matrix, then A equal to half into A plus A transpose plus half into A minus A transpose. Okay, in this conversion, half into A plus A transpose, what we called it? It was called as the symmetric part. Okay, and half into A minus A transpose, known as what? The Q symmetric part. Okay, so, and especially the problems related to conversion of symmetric and conversion of a matrix into symmetric and skew symmetric, we can discuss in the next class. So till then, bye.